Hello students, hope all of you are doing well. Today I welcome all of you in my next video lecture. In this video lecture we are going to discuss about the Lagrange's equation and solution of its using the method of multipliers. In my last video lecture already I have discussed to solve the Lagrange's equation by the direct method of integration. If you have not visited that video lecture, please visit it. Thereafter you come to this for your better understanding. So let us start our today's discussion. So in this video lecture, what are the things we are going to learn? We are going to learn the Lagrange's equation and how to apply the Lagrange's multipliers to solve such equation whenever the direct integration technique fails. So what is the Lagrange's equation by the method of multipliers that we are going to discuss right now? Suppose the given equation is given in the form of the quasi-linear equation capital P into small p plus capital Q into small q equal to capital R. So in the last video lecture already I have discussed about the classification of the partial differential equation and also its solution technique by the direct method. So all of you know from the last video lecture that the auxiliary equation of such quasi-linear equation can be written in the form dx upon p, dy upon q, dz upon r, and all these three factors are basically equal with each other. Now suppose this equation cannot be solved using the direct integration technique, then what we have to do, we have to choose some multipliers L m n or L dashed m dashed n dashed in such a way that we have to multiply each and every factor with these multipliers, and using algebra we can write down the addition of the combination of these terms. Suppose the first factor we are multiplying with L, so it will become L dx upon L into P plus second factor by M, so M dy plus M into Q, similarly n dz by n into R. Similar way we can take another multipliers as L dashed m dashed n dashed such that L dashed dx plus m dashed dy plus n dashed dz upon L dashed p plus m dashed q plus n dashed r. Okay, so these are the two new factors or new terms which we have created. But why? What is the reason for creation of these two factors and what are the advantages we will get? Since we cannot solve these three factors using the direct integration, so this L, M, N are chosen in such a way that the denominator term L, P plus M, Q plus N R, this term may be goes equals to 0. So the denominator will become 0, or else this whole term, that is L dx plus M dy plus N dz upon L P plus M Q plus N R, this whole term will become a differential of u. So d of u upon u. Any one of these two form it should be created by this term. That is why this L, M, N are chosen. Now suppose if L P M Q plus N R is going to be 0, that is the denominator term is going to be 0, then what will happen? We will take this factor with any other factor, maybe dx by p, dy by q, dz by r. So we will get from there L dx plus m dy plus n dz, this quantity exactly equal to 0. Now integrating these quantities or integrating this factor, we will get one set of solution, that is u equal to C1. Similarly from the second chosen multipliers L dashed dx plus m dashed dy plus n dashed dz equal to 0, we get another set of solution, that is v equal to C2. So what will be the general solution? That is phi of u comma v equal to 0, where u phi is the unknown or arbitrary function. So let us try to implement this idea to this question. So let us solve this problem mz minus nyp plus nx minus lzq equal to ly minus mx. So here L, M, N, these are the constant coefficients and this is the term. This is the differential equation. So now all of you can understand that the auxiliary equation can be written in the form dx upon p, that is mz minus ny, equal to dy upon q that is nx minus lz equal to dz upon r, whatever is there in the right hand side, ly minus mx. So we have to take, so let us take the first set of multipliers as, what are the multipliers we can choose? Here is a trick that you can apply. Here if you look at this term, one variable is missing, that is x. Here the variable is y, and here the variable which is missing, that is z. So you can take the multipliers as x, y, z respectively, and give this equation as equation number 1. Therefore the equation 1, another factor will come, and that factor is going to be x dx plus y dy plus z dz, okay, divided by what? So first term we have multiplied with x, so it will come m xz minus n xy plus n, second term by y, n xy minus l yz plus third term by z, so l yz minus m n x. So you can see that, oh sorry, by third term by z, so this is z, mzx. So mzx are going to be cancelled out, nxy cancelled out, lyz cancelled out. So all the terms in the denominator are becoming 0. So this factor is going to be x dx plus y dy plus z dz, this divided by 0 only, right? Now if you just equate this factor with any one of the factor of equation 1, then what we will get? We have x dx plus y dy plus z dz, this term is going to be 0. So if we just integrate it, simple integration, everyone can do this. So this is going to be x square by 2 plus y square by 2 plus z square by 2, that is equal to some constant c1 by 2. Therefore we have the first set of solution, that is x square plus y square plus z square equal to c1. Now one set of solution we got, but we need another set of solution. So for that we need to choose another set of multipliers. How to choose that? If you just look at the terms, whatever in the denominator of equation 1, in the first factor L coefficient is missing, the constant L is missing because m and n are present. Second term m is missing, and third term n is missing. So you can choose the multipliers as L, m and n respectively. Okay, so let us do the calculation. So let us take the second set of multipliers as L, m and n respectively. So the equation 1 will become L dx plus m dy plus n dz, that is in the numerator, while in the denominator what will become? First term is multiplied with L everywhere, so it will be L m z minus L n y plus second term by y, m, so m n What are the equations? Yes, first term by L, so LMZ minus LNY, second term by MNX minus LMZ, and third term by N plus LNY minus MNX, right? So MNX cancelled out, plus LNY minus LNY plus LMZ minus LMZ, so all the terms are getting cancelled out. So in the denominator also we are getting 0. So this equals to L dx plus M dy plus N dz, this upon 0 only, denominator becomes 0. So if we just match this term with any one of the factor of equation 1, so we get L dx plus M dy plus N dz, this is equals to 0. So by simple integration, what we get from here, that is Lx plus My plus Nz equals to some arbitrary constant of integration, that is C2. Since the integration we are doing here, that is indefinite integral, right? Therefore, what is our general solution? The general solution is phi of x square plus y square plus z square. That is our first set of family of curve. Second solution is Lx plus My plus Nz. So this is equals to 0. So this is our general solution. So this is the solution technique. Okay. So let us try to understand all the rest of the problems by the similar method. So let us come to the second question. Say we have to solve the equation x into z square minus y square into p, y into x square minus z square into q equals to z into y square minus x square. So the auxiliary equation is dx upon p, dy upon q, dz upon r, and we will give this equation as equation number 1. Now what we can see, how to make these terms vanish by making the denominator equals to 0. We can see here in the denominator, for the first one only one single x is present, but rest of the terms are square. Similarly here single y is present, but rest of the two terms x and z, these are square, and this is z only, rest of the terms are square. So if we multiply first term by x, again y by the second term, and third by term by z, then denominator also x square y square z square will come, and all the terms can be 0 after adding. So let us choose the first set of multipliers as x, y, z respectively. So what will happen? X dx plus y dy plus z dz in the numerator. Denominator it will become x square z square minus x square y square. Here it is y square x square minus y square z square. Here it is z square y square minus z square x square. So you can see from here x square z square cancel. X square y square cancel. Y square z square cancel. Denominator becoming 0 only. So equation 1, any one of the term is equate with this factor. So if we just take this, so we have x dx plus y dy plus z dz equals to 0. Now simply if we do the integration on each and every term, integration if we do, then what we will get? X square by 2 y square by 2 plus z square by 2 equal to c1 by 2, constant of integration. So first set of solution is x square plus y square plus z square equal to c1. Now we need to solve it again for the another equation, right, another solution. So how to do this? So we can see that first term x single, y single and z single. So if these three terms are not present at all, then also by adding all the terms in the denominator is going to be vanish. So what we can do, we can multiply the first factor by 1 by x, so that x will go, minus 1 by x, so that x will go, 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 1 by x, so that x will 1 by y with second factor, 1 by z with the third factor. So let us take the second set of multipliers as 1 upon x, 1 upon y, 1 upon z respectively. So 1 upon x dx plus 1 upon y dy plus 1 upon z dz. So from first term x will vanish, we have z square minus y square. From second term we have x square minus z square. From third term we have z square minus x square. So definitely all the terms are going to vanish, right, from the denominator. So since all the terms are going to vanish, so this is basically it is my writing mistake. I will do the correction right now. X square minus z square, and this last one is y square minus x square. Okay, so here I have written z square, it's actually this is y square. So y square will get cancelled out. So definitely if we do the integration of 1 by x dx, 1 by y dy, 1 by z dz equals to 0, what is the solution we get? Log of x plus log of y plus log of z equal to log c2. Now we know log a plus log b, that can be written as log of ab. So using that formula we can think that log of x y z on the left hand side, that is equal to log c2 on the right hand side. So we have x y z equals to c2. That is the second set of solution. So what is our general solution then? The general solution will become phi of first factor is x square plus y square plus z square, first solution. Second solution is x y z. So phi of x square plus y square plus z square comma xyz, that is equals to 0. So this is our general solution. Let us try to solve another equation by the similar technique. Solve 3z minus 4yp plus 4x minus 2zq equals to 2y minus 3x. So let us try to solve it. So auxiliary equation we have written dx upon p, dy upon q, dz upon r. So what will be the first set of multiplier? Similar technique. So here which variable is missing in the denominator? That is x. Second, y is missing. Third, z is missing. So first factor we will multiply with x, numerator and denominator. Second factor, numerator denominator by y. Third factor, numerator denominator by z. So after doing this, every terms in the denominator are going to be cancelled out. That you can say or you can verify by yourself. So ultimately the denominator is becoming 0. So equation 1, each and every term is basically equal with this factor also. So we can write down x dx plus y dy plus z dz equals to 0. So now if we do the simple integration, just like the previous two problems, we have the solution of the first term x square plus y square plus z square equal to c1. Let us take another set of multipliers. So if you just look at this question, in the first factor the constant 2 is missing, in the second one constant 3 is missing, and third one constant 4 is missing. Therefore we have to multiply the first factor by 2, second factor by 3, third factor by 4 and adding. So if we do that, here also the denominator terms are going to be cancelled out, right? So denominator is going to be 0. Since denominator is 0 and equation 1 every term is equal with this factor only, therefore this factor actually is going to be 0. 2 dx plus 3 dy plus 4 dz equals to 0. So now if we just integrate this, what we will get? 2x plus 3y plus 4z equal to c2, right? Therefore what will be our general solution? The first solution curve is x square plus y square plus z square. Second solution curve is 2x plus 3y plus 4z. Phi of this two equals to 0. That is our general solution. Now let us come to the next problem that is quite important and very important for your understanding and exam also. So for the last three problem, we can see in the denominator whatever terms are given, there in between we are having minus sign. But here look at this problem, it is given as y plus z into p plus z plus x into q equal to x plus y. So here all the terms are positive, so you cannot vanish it, right, by choosing any kind of multipliers. So what we have to do, we have to think up in a different way. So at the starting I have told you, you try to make either the denominator equal to 0 or you can take the whole factor as a total differential operator, that is d of u upon u, total differential term. So let us do in the second approach, not making the denominator 0, but try to make the whole factor as a total differential term. So the auxiliary equation of the given equation is dx upon p, dy upon q, dz upon r. Now what we are doing, we are taking the first set of multipliers as 1, 1 and 1. So every term we are multiplying with 1 and adding. So equation 1 takes the form dx plus dy plus dz upon every terms in the denominator are coming 2 times. So we have written 2 into x plus y plus z. Now this dx plus dy plus dz term, can be easily written as differential of x plus y plus z, right? Because differential of x plus y plus z, that is going to be dx plus dy plus dz. Okay, so this can be easily written in this structure. Similarly, let us take the second set of multipliers as 1, minus 1, 0. First factor by 1, second factor by minus 1, third factor by 0. So what will happen? It will become dx minus dy plus 0 dz divided by y plus z minus x plus 0. So you can see, if I take dx minus dy, so this terms can be easily written as a differential form, that is d of x minus y, and here in the denominator z cancelled out, minus if I take outside, it can be written x minus y, the same term x minus d of x minus y upon x minus y. Similarly, we are taking the third set of multipliers as 1, 0 and minus 1. First term by 1, second term by 0, third term by minus 1. So again we are having similar type of case, that is d of x minus z, denominator minus, if we common, then we are having x minus z. Now see what is happening. The given equation 1, the auxiliary equation, basically is equal with 2, 3 and 4, but 1 we cannot solve directly, but 2, 3, 4 are already in the form of the total differential operator formula, right? D of something by something, because the same term is there, x plus y plus z by x plus y plus z. So it can be imagined as d of u upon 2u. This can be imagined as d of u upon minus u. This can be imagined as d of u upon minus u. So these terms can be easily integrated and we can find out the solution. Therefore, since 1, 2, 3, 4 all are equal, so I can take any two terms, right? So I am taking first 1 and 3. So if I take 1 and 3 together, so d of x plus y plus z upon 2 into x plus y plus z equals to d of x minus y upon minus of x minus y. So if I just do the integration, what is the integration of dx upon x? That is log of x. So this is 1 by 2. I have missed to write down, here it is. So 1 by 2 log of x plus y plus z, it will come, right? Now similarly, if I do the integration of the second term, minus sign is there, it will become log of x minus y plus log c2. So here it will come as, it will go in the power, because you know that is anything comes in front of log, it will go in the power of the term. So it is x minus y, I am taking in the left hand side. So this minus log, it will become plus, right? So log a plus log b is going to be log of a into b, and log will be cancelled down on both sides by taking exponential power. So it will be x minus y into x plus y plus z whole to the power half. This is equals to C1, first set of solution. Similarly, you can take any other two factors. You can take 3, 4, you can take 1, 4, you can take 1 or 3, any other factors. So I am taking 3 and 4. Sorry, 3 and 4. I am taking 3 and 4. So if I take 3 and 4, what are the terms I am having? D of x minus y by minus of x minus y equals to d of x minus z by minus of x minus z. So simply if I integrate these two terms, what I will get, this minus sign automatically get cancelled out from both sides. So since it is d of u upon u, so what will be the answer? That is log of x minus y. Similarly, on this one, it will become log of x minus z. plus log c2. Now take this log x minus z from right hand side to the left hand side. It will become log of x minus y minus log of x minus z. So log a minus log b is log of a upon b, right? So it will become x minus y by x minus z, and this log we can cancel by taking exponential power, so it is like this. So what is the general solution? X minus y into x plus y plus z whole to the power half, and x minus y by x minus z, this is equals to 0. So this is the solution. Let us come to our next problem, or the fifth problem of this video lecture. Let us solve z square plus y square plus z square minus x square into p minus 2xy into q plus 2xz equals to 0. Remember one thing, left hand side coefficient of p, coefficient of q is there, but it will come right hand side r, but this plus 2xz you have to basically take it on the right hand side first. Okay, so dx upon p is y square plus z square minus x square, dy upon q is minus 2xy, dz upon r is, if you take it on the right hand side, it will become minus 2xz. Sometimes students make mistake, that's why I have given the equation in this structure. So from second and third factor, it can be solved very easily, right? Dy by minus 2xy equals to dz by minus 2xz. So simply this 2x plus minus sign, it can get cancelled out. So you have dy by y, dz by z. So simply if you integrate these two terms by direct method, it will be log y equals to log z equal to log c1. If you take log z on the left hand side, it is log of a minus log of b. So log of a by b it will come. So it will become y by z equal to c1. So this is our first set of solution. Now let us come to the second set of solution. But the second set of solution we cannot bring without using the Lagrange's multiplier, because no direct integration can be done. If you take first and third or first and second, no direct integration can be performed. So what we will do, let us try to multiply with the factors x, y, z. Why I am multiplying with x, y, z? Because I know here every terms are coming as a square, right? And no x is there. But here if I multiply with y and third term by z, so xy square, xz square are going to come in the second and third factor, and here xy square, xz square are going to come in the first factor. So something will get cancelled out, so we will get some simplified form. That's why we are taking the set of multipliers as x, y, z respectively. So first term by x dx, second term y dy, third term z dz. What we get? xy square plus xz square minus x cube minus 2xy square minus 2xz square. So here it is plus, here it is minus. So it will be minus xy square. Similarly plus xz square minus 2xz square. So 1 minus xz square will remaining, and minus x cube. So all these three terms are containing minus x. So if I take minus x common, so it will become x square, y square, z square. Say this is our factor number 2. Since equation factor number 1 and factor number 2 both are equal, so I can take any one of the factor from the first one, right? So I am taking the last factor of the equation 1 and this factor equation 2. So what I will get? So dx upon minus 2xz, this is equals to x dx, y dy, z dz by minus x into this. So definitely this minus x is going to be cancelled out. This can be done very easily. Now this 2, that is 2z is there, dz upon 2z is there. This one, this is x square, y square, z square. If I differentiate this, x square plus y square plus z square, if I differentiate it, what I will get? I will get 2x dx plus 2y dy plus 2z dz, right? But in the numerator you see no 2 is there. So this 2 basically I have to adjust. So that is why I have taken 1 by 2 outside, and thereafter I am taking differential of this x square plus y square plus z square. Already denominator x square plus y square plus z square is there. So we will just integrate these two terms. So what we will have? 1 by 2 is already there. Sorry, I have missed earlier. So it will become integration of 1 by 2 dz upon z is log z. 1 by 2 log of x square y square plus z square plus log c2. So this half you can cancel and adjust with c2. So this square root definitely it will not come. This square root it will not come. So if you take this on the left hand side, you have log a minus log b. So log z upon x square y square plus z square equal to c2. So what will be our general solution then? First set of curve we have y upon z. Second set of curve square root it will definitely not come, because I have not taken that 1 by 2 with that, that's why I have mistakenly written this. So the second set of curve is z upon x square plus y square plus z square equals to 0, right? So this is the general solution. So these are the topics that today I have completed. So what we have learned, that we have learned how to solve the Lagrange's equation not using the direct method of integration, and how to choose the Lagrange's multiplier to solve those kind of problem very easily. So here I have given some exercise questions to you. You please go through these questions, try to solve it. If you are not getting the solution, please let me know in the comment box by making your comment. And if you understand this topic, if you like this video, please share with all of your friends. Thank you all.